Okay, let's do this problem, another grade 12 trigonometry problem. And this first looks intimidating, but we can work with what we know about the sine graph to simplify sine of x minus 540 degrees. We might notice that 540 is just equal to 360 plus 180. That's helpful to know. And you could think about this a couple of different ways. One would be thinking about the sine graph and knowing that 540 is 1.5 times the period. So a full graph goes 360 and another 180 is another half of a wave. So we notice if we look from, say, 90 degrees, if I add or subtract, to be honest, 540, I'm going to be down here at the bottom, because if I add 360, I'm up at the top, and then another half a wave, I'm down at the bottom. And the value of the sine is exactly opposite. So this equals the sine of x, but the opposite of it. We can also see this if we think about the unit circle. For any value, call this angle x, if I add 540 to it, so I go around and add 540, there's plus 360 plus another 180. We notice that the sine, which is the y value, becomes the opposite. So we know that this first term will be the opposite of the sine of x. And then we have this next part, cosine of the opposite of x. We're going to square all of that. Well, the cosine of the opposite of x has to do also with the cosine graph. We could consider, because this is an even function, that means it's symmetric to the y-axis. This is the cosine graph. Earlier we were looking at the sine graph. We can see that for some angle and its opposite, the cosine's actually equal. The y value is actually equal. So we can always say that the cosine of the opposite of an angle is equal to the cosine of the angle. While we're talking about that, if we did have a problem with the sine of the opposite of the angle, that's equal to the opposite, the sine of the angle, and that's also true of the tangent. Oops. Those are odd functions, and they are symmetric around the origin. But that's a little bit off track here. Okay, so let's get back to the problem. So we know that cosine of the opposite of x will equal cosine of x. And now this is mostly an algebra problem. I'm just going to take out a -1, and we can square that, and we're left with sine plus cosine. You didn't have to take that out, but it makes things a little bit easier. -1 squared is just 1. And now in order to expand sine x plus cosine x squared, we need to consider it two binomials. So we have sine squared, then we'll have our middle term, 2 sine x cosine x, and our final term, cosine squared x. Well, you know from your Pythagorean identities, sine squared plus cosine squared is just equal to 1. So now we have 2 sine x cosine x plus 1. And you might recognize 2 sine x cosine x as the double angle formula that's equal to the sine of 2x. So I think that has been simplified. So the formula we use, two formulas we used there were sine squared plus cosine squared is equal to 1, and sine 2x is equal to 2 sine x cosine x. Of course, we had these even and odd formulas as well.